Okay, so let us continue the lesson. Can you summarize it for me? If I want to find the fixed point, first of all, the Banach fixed point theorem only works if you want to find the fixed point of what? I just want to refresh your memory. This theorem doesn't help me to find the fixed point of any kind of functions. For example, it was completely useless for that high school problem I just started today with y. It was 2x squared plus 3x something. Why do you think that this theorem is not applicable to that function? Because that function is not a contraction. Okay? So remember this fact. If you want to use Banach fixed theorem to find the fixed point for a function, that function should be defined on a complete metric space to itself, and it should be contraction. Otherwise, it is not helpful. Okay? So, but if it is, how do you do that? How do you find the fixed point? The proof of the theorem. That's why I'm saying that you need to remember the proof somehow. So how do you do that? I give you, let us, for example, this example as you see here. It's a very, every high school student can solve this in a matter of 1 second. Okay? But we want to make it the other hard way. Okay, so let us, this is instructive because you see how it works. Okay, so let me, for example, here I have example 8.6. I have this function phi from R to R, and I have defined it phi x equals to x plus 1 divided by 2. And you see here, I am asking you to show that this is a contraction. And the space that I am working on R without mentioning the metric. So by convention, it is the Euclidean R. And Euclidean R, do you remember yesterday that it is complete? Okay, so that's good. So, but the only thing I want to justify is this, is it a contraction or not? So how should I test if it is a contraction or not? I have to net here, because my metric is the Euclidean metric. It's not mentioned in the problem anything about the metric, so by standard convention, it is the Euclidean metric. So what I have to do, I have to calculate the distance between phi x, so I would say let x and y be in my metric space. Then what I do, I measure the distance between phi x and phi y to see how it goes. I want to show that it becomes less than or equal to a factor multiplied by the distance. So I will continue. The distance between these two in this metric space is the absolute value of phi x minus phi y, because my metric is this. But phi x is what? Simply x plus 1 divided by 2, minus phi y is simply y plus 1 divided by 2, but simplification is extremely simple. 1/2 and 1/2 is gone, so this becomes x minus 1, x minus y divided by 2, which I can write it as this one. And do you agree that this one is also is equal to the 1/2, the distance between x and y? And of course, I can write it as less than or equal to this one. It doesn't hurt, because that is not false. This one is less than or equal to itself. Yes? But what is it a contraction now? So look here and there. This number is always less than or equal to 1/2 of this number. And this number is between 0 and 1. So it's a contraction. So thus, phi is a contraction with parameter 1/2, for example. So can I apply Banach fixed theorem to this to find the fixed point? The answer is yes. But do you remember what was in the proof? How can I come to that fixed point? I pick a random point in my space and apply phi on it recursively. I generate a sequence and take the limit of that sequence. We proved that it is convergent at that number is the fixed point. Of course, what is the fixed point? Can you calculate it in your head? So you want the fixed point. It means that phi p should be p. So this means p plus 1 divided by 2 is p. So p is 1. So that's why I'm saying that a high school student can solve this in a matter of 2 seconds. That's your fixed point. But we want to do it in a hard way. So you pick any random point. I have given you some, because you don't know the fixed point, if you are so lucky, the first point you randomly pick is just that fixed point. Okay? And I have written in the notes what happens if you do that. That's the best scenario. Okay? But that's also good to think about this, talk about this a little bit here. I forgot to mention it. So what is important? Do you remember when I was doing the proof, I picked a random point there. And that random point that didn't matter because it generated the sequence from that one point. And then we showed that this sequence converges to the fixed point. Okay, there is one question. Might be you choose a different initial point. Then, of course, your sequence would be completely different. Yes? But the good news is that it doesn't matter. Both of you will converge finally to the fixed point. But what matters, do you think? Do you think it is completely irrelevant if we want to talk about a good starting point? I have written in the notes, if you choose something appropriately means that if you have a feeling about where the fixed point is and try to choose a number close to it from the beginning, you can reach to P faster. Your convergence rate will be faster. But the good news is that if you don't care about speed, finally you will reach the destination. Okay? So that's the whole thing. I want you to remember that. Okay? So if you have a rough estimate about the initial point, it is better to go choose the point close to it. And I have written in the remarks why this is going to be the case. Think about it yourself first. Go through the proof and see which formula in the proof justifies this. Which part will tell you that if you choose a point close to the real fixed point, which you don't have any clue for it, because if you know why you are looking for it, yes? But it will matter. Okay, so now let us go and try to do it in the hard way to see that finally we can get this by the method in the proof or not, because it will help you to learn the proof. So which number you want to choose, for example? Do you want to choose 2? So let us see what happens. So let us choose P1, okay? So let us choose P1, any number you'd like, yes? Sorry, not in R. Exactly, so you would like any number, P1, let us choose. Okay, so tell me, how should I construct my sequence now? My sequence should be constructed recursively by the contraction map. Okay, so this is the only thing you need to remember. Okay, so now, what does it mean? It means, this is Pn plus 1. Pn plus 1. Okay, so this means that this is equal to phi pi n is pi n plus 1 divided by 2. So of course, you shouldn't expect to get your sequence, you get your sequence recursively. That was the condition, yes? So this means, have you seen these kind of things in your discrete mathematics? Because this is a sequence, it's not a good sequence. Why? It is defined recursively. So I want to find the limit of this one. How can I find the limit? One way is to do what? Because it is not always possible. One way is to find the formula for Pn in terms of n. Okay? Can you do that? No? Yeah, in this one, I know what to do. Okay, the trick is simple. So let us do it. I want to find Pn in terms of n. Okay, so if I subtract 1 minus 1, do you agree this happens? The left-hand side, I subtract minus 1. I put minus 1 here. I take the common denominator. 1 minus 2 is minus 1. Yes? Is that right? Why this is helpful, do you see? Because if I call this one, as I did in my notes, En, what do you call this one then? If this is En, what is this one?
En plus 1.
En plus 1. Do you agree? But En plus 1 is 1/2 En. And now it is extremely simple to guess the formula. Because the next term is just 1/2 multiplied by the previous term. So if I ask you, can you tell me what is En? Can you answer that? The first term is E1. The second one is 1/2 E1. The next one is 1/2 of 1/2 E1. So it becomes 1 over 2 to power n minus 1 E1. Am I right?
Yes.
Every time because this relation is easy to solve. Every time I am multiplying by a factor of 1/2. So it is very clear that En is 1 to the power of 2 to power n minus 1 by E1. And then I replace them. What was E1, do you remember? What was En? En was this guy. En was that guy. So it becomes Pn minus 1 is equal to 1 over 2 to power n minus 1 times E1. But what is E1? E1 is P1 minus 1. Do you agree? Okay. So I am looking for Pn. I am done, yes? So Pn becomes P1 minus 1 divided by 2n minus 1 plus 1. So that is your formula. Yes? What is my goal now? Do you remember? My goal is to find the constant. Do you remember in the proof, in the process of the proof, what was P? P was the limit of this sequence. So my fixed point is the limit of Pn when n goes to infinity. I have to take the limit of that. So this becomes the limit P1 minus 1 divided by 2n minus 1 plus 1. N goes to infinity. Remember, if I ask you what is P1, P1 is just a constant, whatever number you like, 2, 5, 7, any number. So what is this limit now? The numerator is a constant, this is infinite, the limit becomes 1. So this is the hard way to solve a simple problem. But you didn't need to do that because there is a very simple trick to find the limit here without finding the formula. Can you tell me how? We did it during the proof in a disguised form. But of course, it works if I know the sequence converges. But is it guaranteed that this sequence involved is convergent? Yes, because we see it in the proof. We saw it in the proof. So if I know that sequence Pn converges to P for the same reason we discussed, this sequence will also converge to P because it's a subsequence. So what I do, if we know Pn converges to P, which we know from the proof, then Pn plus 1 converges to what? P as well, because that's a subsequence. Okay, now what I have? I have Pn plus 1. Remember this, by the way, this is a very important trick. So I take the limit from both sides. Okay, so let me underline this. This technique only works if we already know my sequence converges. This technique works all the time. I proved it is convergent and its limit is 1. because I calculated the limit. Here, I'm not calculating limit. I'm assuming that my sequence converges to some number p, then by a theorem or for subsequences, this also converges to p, so I can take the limit. And then what can I put instead of this guy? I can put p. What can I put about this limit? What is this limit? This is a constant, this is constant, so I take the limit of this one, which becomes p. And that is exactly that equation. So that p becomes p. Yes? For example, one of the examples one of you asked me, I have given you a question, if I remember correctly, in the sequence part. If I remember, I think it was something like this. Okay, so let us see if I have time, I will solve for you. So I have asked you to find the limit of this. Okay? So if you write in the exam, I take the limit from both sides, this limit is L, this limit is L, and I solve that and find L, this is my L, I will not give you the full marks because you have to prove that first this limit exists and then find that one that exists. If you drop that part, even though your limit will be correct, but it is not the proof of existence of a limit. You understand what I mean? That is exactly what I'm telling you here. Okay, any questions here? I found a very nice example from exam last time. This is the latest exam. Okay, so let us solve this together. That's a very good question because it is not very trivial. Okay, for exam, it's a bad question from a student's perspective, but for me, it was a very nice question. Okay, so let us go through it and solve this together. Okay, so let us read it first. 2025 August. Yes, question 7. That's the last question, or no, 1 to the last or something like that. So let m be 0 and 1 squared. I mean, you can imagine that. What is that? M, if I want to draw a picture. So exam question. So the exam, this is telling you that m is 0, 1 squared, which is of course 0, 1 cross 0, 1. If I want to imagine it, here is 1, here is 1. This is your m. This is m. Yes? Okay. And then they have defined a metric for you. You see that? Do you remember which name I gave to this metric when I was teaching you the metric spaces for the first time? dA and B is the maximum between the difference between x coordinates and the difference between y coordinates. I called it taxicab metric. Okay, so that's a taxicab metric. And this is interesting. You are not supposed to prove it. It can be proved that m, this square with metric d defined up the line above, is a complete metric space. So this does not need to be shown. You're not supposed to show this is a complete metric space. The designer of the question is granting you that. So, and then formulate Banach's fixed point theorem, which I skipped this one. That's exactly the meaning. So you just need to write the theorem itself. What was the theorem? Do you remember? If x and d is a metric, complete metric space, and phi from x to x is a contraction map, then there is only one fixed point for this contraction. So you write that. That's exactly what I mean. I will also ask some questions now. But now, part 2. I want you to see it a little bit yourself so that I write the question here. Think about it. How is it related? And they have also given you a hint. Without that hint, it would be hard. So this is one structure of my type of my questions as well. If the question is hard, I will definitely provide you with hints. Okay, so might be step-by-step hints. So try to read it yourself first. So do you have any clue? So you see, it is a non-trivial question. Oh, that example was very trivial. You might say, why we suffer so much to learn about fixed point? But because you know that this is not a standard, but of course, this is by the way. Now I understand it's also trivial. Yes, because we can solve the system very simply. Yes, because this one is repeated here. You can put them and find the relation between x and y and put it back in one of them and find the x and y. Yes, so it is also trivial. So, okay. I will try to make it non-trivial in the exam, but it doesn't matter, okay? If you solve it from that way, by the way, the proof is complete because you find one fixed point according to the method you are doing. But they have emphasized you have to use the Banach fixed theorem. Okay, so let us do that. One thing that is important for you is that if this was not given to you as a hint, could you really more or less come up with this yourself? If you want to do that, you have to formulate your problem as a fixed point problem in a complete metric space. When you read the first line, they are telling you, take this for granted, that this M with the taxi cab metric, yes, a taxi cab metric, this M, this one is a complete metric space. So this is granted for you. Okay, so now, if I ask you, what is the meaning of a fixed point of this map? What is the meaning? Can I say, for example, 5 is a fixed point of t? Why not? It is grammatically wrong. Why? Because the fixed points of t should come from this square. This square, the points of a square is not numbers or couples, yes? Okay, so now if I ask you, if I choose one x and y in my metric space, how do you know if x and y is a fixed point of this t? How do you know that? You have to solve this equation. Yes? T acting on that point should be itself. Then it means this point is a fixed point for my function. Do you agree? But now, go to a scratch paper and see what happens. Tx and y is this expression. So if you write that, yes, and equate it with x and y, what do you get? You get the first one is equal to x, which when you multiply by 8 give you the first equation. And the second one is y, when you multiply it by 8 gives you the second equation. So this means that this system had nothing to do with the Banach fixed point theorem. But one way to look at the solution, finding the fixed point, finding the solution to this, is through the Banach fixed point. Here you have to be creative a little bit to come up with a function whose fixed point problem boils back down to your problem. And hope for the best that you can use the techniques to solve the problem. Is that clear? So in principle, it was not that hard here. Now, why do you think that, so 8 should be there, yes? Because, for example, if 8s are not there, this problem will not be this problem, yes? Because then 8s are gone, that is not my problem. But one reason that the author has written this 8, if 8 appears here, what do you think it will happen? Why is 1 over 8 is somehow important? For example, I don't know, we can turn this to 1 over 8, yes, and turn this one to 8. That's also a fixed point. But the problem would be what? Do you think that problem can also be somehow solved by Banach fixed theorem? My guess is that because in Banach fixed theorem we need a contraction. So this factor will be important to make that lambda between 0 and 1. That is my guess. It might be the other way around, wouldn't work. Okay, anyway, so you understand that if this problem was given to me, I could solve this problem and prove that this is a unique fixed point, this has a unique solution without even using this method. But I want you to understand this could be more complicated. But for example, later you might see that equations involving integrals. And there is not simple way even to find the x in which an integral becomes equal to another integral plus an expression. So you will see one of these examples. What I want you to know is important. Okay, so now tell me, if I want to solve this problem in the exam, part 1, you wrote it down, it is finished, you want to start part 2. What is the first thing you do? What is the first thing you do? You prove what? Because you are supposed to use the Banach fixed theorem. And they have asked you to use this function. Banach fixed theorem does not work for any kind of functions. It only works for contractions. So the first duty is to prove T is contraction. Okay? So that is the only thing you need to do with this exam question. We want to prove that this is contraction. Okay, so do you remember what was my metric? Metric of A and B. If A is equal to A1 and A1 and A2, B is equal to B1 and B2. The taxicab metric was defined to be the maximum of absolute value of A1 minus B1 and absolute value of A2 minus B2. Okay, so let us start. I want to prove that this is a contraction. I have to prove that the distance of, can you help me to write something? I want to show that T is contraction. I need to show the distance between what? T acting and T acting. What should I write here?
T acting on.
What? X1 and X2, X1 and Y1 with
X and Y.
X2,
X2 and Y2.
Y2 is less than or equal to some factor multiplied by, this is a scratch paper work if you want, multiplied by, can you fix it?
The distance of X and Y. Okay.
X1 and Y1 and this. So this is something you write in the scratch paper to motivate you how to proceed. If I can show this is, and then I can find this factor somehow, and I am lucky that that factor is between 0 and 1, then I am more or less done. I actually completely done, but I need to write some sentence at the end. So let us try to do this together. So let us do D Tx1 and y1, Tx2 and y2 is equal to. So D, let me write the formulas here instead of these two. It is a little bit complicated, but it is not hard. So Tx1 and y1, I replace x1 and y1 in this formula. Okay? So this becomes, if you don't mind, let me write it as a fraction. 2 am I right? Yes, do you agree with me? Okay, but now what should I do? I want to find the distance between this a little bit complicated point and that point. But my distance is taxicab metric. So for finding the distance between these 2 points, I have to find the absolute value of the difference between x coordinates and the absolute value of the difference between y coordinates and look at the maximum. Okay, so I will do that. First of all, I will copy and paste maximum. The absolute value of the difference between x coordinates. So what happens? Do you agree that I can write it as 1 over 8 here? 2x1 squared plus y1 minus 2x squared minus y2. Yes? Absolute value closed. And the absolute value between the y coordinates. Okay? The denominators are the same. So 2x1 squared plus y1 plus 3 minus 2x squared. Yes. Yes. 2x squared minus y1 minus 3.
Y2. Yeah, it's Y2.
Oh, y2. Right. This one is y1, this one is y2. Yes. And if you don't mind, let me just drop these trees, okay? Okay. This should also be curly brackets. Okay, so let us start with one of them. I will bring this down and start working on it. So between these two, so do you have any idea what to do? You should have an idea because you know you shouldn't get complicated. Because you go to a scratch paper, what is this one? This is the maximum between x1 and x2, x1 minus x2, and y1 minus y2. So I want to make that appear. So then it will give you a line how to proceed. You know, because this algebra could be complicated. How should I know what to do? I go to a scratch paper and I will try to understand that formula. If I want you to write this formula for me, what do you write? You would write the same thing. You would write maximum of absolute value x1 minus y1 and x2 minus y2. Do you agree? This is what you have. So this already tells you that it is good to collect and make these expressions appear here. If you have this strategy in mind, that is not hard. So if you don't mind, let me call this one capital A and start writing capital A here. So now how should I collect the terms? Do you see that? Because my goal becomes clear. Between these two, I factor a 2 and I have an 8. So it becomes 1 over 4, x1 squared minus x2 squared. And then between these two, I would write 1 over 8, y1 minus y2. Do you agree? And then I have an absolute value. This one is good enough for me, so let us not tamper with that. But this one is not good because I want a first degree. Oh, I made a mistake or what? No, that is correct. So that was my mistake. x1 minus x2, the difference between x coordinates, the difference between y coordinates. Sorry, this one is the correct one. Yes. Okay, so this one is good because it appears, but this one is not exactly what this is, but I know the conjugate rule, okay? So it becomes 1 over 4, x1 plus x2, x1 minus x2, and then I have plus 1 over 8, y1 minus y2. Okay, now tell me, what should I do? Be careful, you do not want equality. So you don't need to make it equal, you want to have inequality. So what things come to mind? You want this to appear, you want this to appear somehow, but you also don't want to stick to equality, which is very strict. So one thing comes to mind is triangle inequality. Could you see that? So this becomes less than or equal. This is the absolute value of a sum. So it becomes less than or equal to the absolute value of the first one plus the absolute value of the second one, yes? But now let us do some algebra here. We are running out of the board, yes, and time. Okay, so 1 over 4 can be pulled out. So let me pull it out. This absolute value can be written as 2 absolute values. Absolute value of the first one multiplied by absolute value of the second one. And this 1 over 8 can also be pulled out. Do you understand that? Because the absolute value of a product is equal to the product of the absolute values. Again, what is the only problematic term here for me? I like this one because it is supposed to somehow appear. I like this one because it is somehow supposed to appear. I don't like this one because it is not supposed to appear. So I have to get rid of it. How can I get rid of it? Again, not by equality. Equality is very strict. You can have inequality. Where x1 and x2 are. x1 and x2 are somewhere on this x1 and x2. So both of them are between 0 and 1. Do you agree? Because I have chosen my points from this square. So x1 is minimally 0, maximally 1. So what is the upper bound of x1 plus x2? 2. So this means that this is not equal, but it is strictly, it is less than or equal to, if this is 2, it becomes 1/2. Is that right? Okay, but now you have to do something similar for B, but I want you to do B in your head. Because the algebra is extremely, by the way, is it exactly identical?
Yeah.
Yeah, because the 3's are gone. But it's exactly identical. So we don't need to do that because I can write B is equal to 8. Yes, they are the same. Okay, so B is equal to 8. So this means that if I ask you what is the maximum, by the way, the maximum is A itself. Yes, because both of them, I didn't see that in the beginning. Both of them are the same. So the maximum is one of them. Okay, and then we learned that this one is less than that one. But there is a small problem here. Yes, what is that? I want to go for this one. So I have another inequality again. So can you finish it? Because you remember, what do I want to have on the right? On the right, I want to have this. I haven't achieved the goal yet. On the right, I want to have B, which is this one. I was doing great up to here, but I have to finish it. I would write it is less than or equal to, finish it, 1/2. Let me write something. Do you agree with this one? Yes? Because D is maximum of these two numbers. Is that right? So this one alone is smaller than this one. Do you agree? And this one alone is smaller than the same thing. Do you understand that? So up to here, I am sure that you understood. From here to here, my claim is that this one alone is less than this, and this one alone is less than this. If you agree with this one, then hopefully you agree with what I have written. But why you should agree that this one is less than this? Because this one is maximum of them. Yes? And the maximum of this is definitely bigger than every one of them. Or I am right or wrong. Yes? Questions?
And we just, since 1/2 do that plus 1/8 of it, can we just rewrite the...
I will write it. But
no, but...
So this becomes equal to 5/8.
Yes, but in the previous step,
Yes?
can't we just say that... Oh, no, sorry.
No, I don't think. I think this is the only way. But I want you to understand what I have written is correct. So if I give this a name C, if I write x1 minus x2 is less than or equal to C, do you agree or not? Because C is the maximum of this with something else. So definitely it is greater than C. And for the same reason, do you agree y1 minus y2 is less than or equal to C? Yes, because that's the maximum of these two numbers. Yes or no?
Yes.
Yes? You don't look happy.
I am happy.
Are you happy? Okay. Okay, you have to show you are happy. How can I know? Okay. So then 1/2 of the same number of this number plus 1/8 of the same number becomes 1/2 plus 1/8. What is that? 5/8 of that number. Yes? Sorry, this is a bad thing. So this should come after that. Yeah, but so this becomes equal to what? 5/8, the distance of x1, y1, and x2, y2. So finally, I hope that you agree this is a contraction. Is that? Because the distance of these two for any chosen point is less than or equal to this factor of the distance of the original points. And that factor is somewhere between 0 and 1. So actually that was the exam question in the hard part. Yes? I have given you 1 or 2 of these type of examples in my notes. So please study them. You will get 1 question of this type in the exam, so it's already clear. Yes. So I mean, fixed point is 1 question. There is another one that I will teach you. I saw it's also a good question, but we have to do it when we learn the integrals. Okay? Any questions? Okay, thank you very much.